So welcome to the session, sir.
Okay, sir. Okay, thank you. So,
I
just
will
an
tell one, two lines about you here,
yes, yes.
and
Okay,
I will hand over the mic to you, sir.
okay, sir. Thank you. Sir.
Um, so, uh, good afternoon to you all. Actually, now we are going for the session, the pre-launch session, last pre-launch session, that will be taken by Dr. Rabindra Kumar Barik, uh, who has done PhD in geoinformatics and has got a vast experience of research and application of cloud computing, GIS, remote sensing in different fields. And he will actually deliver a talk on open source GIS solutions for geospatial cloud computing. Already you are in touch with him. He has solved a lot of problems that you have raised, and I hope you will enjoy this session. And in fact, uh, keeping in view his hands-on integrated with this session, and keeping in view the importance of this particular subject, that is open source GIS solutions for geospatial cloud computing, we have decided to extend the session up to 2 p.m. and I hope you will enjoy, and definitely you will long for more. Though in present FDP there is no scope for more sessions, but subsequently in future actually we are looking forward for many more such FDPs and many more such other workshops, conferences, where we will definitely as you can share your experiences, and you can gain a lot from Dr. Rabindra Kumar Barik. Sir, I am handing over the mic to you. Sir, please start.
Okay, sir. Thank you, sir. So, namaskar to all of you. And so today we'll see one of the interesting topic. Maybe it is much more suitable for your research, and maybe it is in terms of theoretical aspects. It is also a very broad area. Nowadays, everything is in cloud environment. So it has also be one of the good area, and you will get lots of research as well as the in theoretical aspects you will get. And according to this topic, open source GI solutions for geospatial cloud computing, is that first of all you have about the, as we have going through the so many sessions or so many work you have done through the open source GIS, as in your quantum GIS, isn't it? So in quantum GIS, I hope the main problem is that in open source, whatever I have from the last, I have worked in open source from last to maybe during my MTech and PhD from 2007 to till now. I'm also working this open source GIS software. The main problem is that there are versions, isn't it? So somebody is telling, sir, I have working in 3.14. Somebody is telling, sir, I'm in 2.1, 2.6, maybe 2.18. So that means it has some so they have also be good benefit also there, and also they have some problem with the integration of all these versions. During my PhD also I have integrated 17 to 18 open source software, but main challenging is that to cope up with their versions collaborations. Okay, and also the lack of some of the documentations of this open source software. So that is also one of the main challenging issues, isn't it? So in our FDPs, all of you have somebody is telling, sir, I am working 3.14, but I haven't find any for saving any save file in or to copy any save file from from this layer to this. But you will find, and one more thing is that whatever you are raising your things, one of the best friend nowadays in our in this pandemic situation is with the Google. Whatever you have to find, you everything you will find through the Google. But the main thing is that how you can searching out through that search mechanisms. So in this case I will tell about the greatest benefit about the open source GIS software, how we can implement this geospatial cloud in framework. So in this session, actually I will tell about two open source aspects. Two open source software is there. One is for quantum GIS. As you all of you know, quantum GIS is be uh, you have working on that, and in quantum GIS they also facilitated to achieve your geospatial cloud computing. As I have also mentioned, I have given in your group that you have to install your plugin in your quantum GIS framework, that is QGIS cloud plugin. Okay, so so anybody else facing any problem to install the QGIS platform? Please tell me, anybody having any problem to install that QGIS cloud plugin platform? Yes. Anybody having any problem for installing that QGIS cloud plugin platform? Because whenever I'll do the lab to the demo sessions, then I think all of you have integrated that framework also. Is there any problem to integrated QGIS cloud plugin, to install the cloud plugin in your QGIS platform in your desktop versions?
Sir, we have downloaded, but we did not install.
No.
Yes, sir.
QGIS plug. No. QGIS plugin. It is. You will not download that one. You have to just click on. Okay, you have all having your QGIS with you.
Yes, sir.
Yes. So in QGIS, okay. So you just see the plugins. One menu is that plugins. Yes. In plugins, you will find in manage and install plugin. Their option is there, manage
Yes,
and install plugins. There you have to search QGIS cloud. Yes, just go to the plugins, and I'm using 2.18 versions. Maybe in 3.14 is there, and plugins. Yes, in plugins you just click on manage and install plugins. There you can search it out, QGIS cloud, QGIS cloud plugin, QGIS cloud plugin.
Yes, sir. We got it, sir.
Yes, you just click that one and you just install plugin. Yes, and you know that QGIS is one of the highly rated open source software, because due to the Python has given all these plugins, thousands of plugins. In Delhi you will find that new plugins has been designed, and it has been uploaded in our GitHub. GitHub is also be one of the main challenging hub where you can find all these open source code. Whatever you have to want in QGIS. Which versions you are working, ma'am? Yes, tell me which versions of QGIS you are working.
3.14, sir.
3.1. Ma'am is telling that. Yes.
Sir, 3.14.
Okay, there is no any plugins menu.
Sir, there is no.
What?
There is no GIS cloud, sir.
GIS cloud. QGIS plugin. QGIS cloud plugin.
नहीं सर नहीं है सर वहाँ पे.
Sir, please check and we'll see. Okay.
Sir, I got it. Like,
sir, it is on. It is on there, sir. It is on QGIS plugin.
Okay. So that one also I will tell about how we can to invoke our Geospatial cloud platform through that QGIS plugin, and also I have telling that you have to make your own cloud based framework. Means you have to sign in that QGIScloud.com according to your email ID and all. You just sign in that. I hope all of you have to sign in that case. So I hope all of you have your own site has been already have given there. Just I am giving again that link. Yes, I am just giving that link.
QGIScloud.com.
Yes. So I hope all of you have done that one. Again, I am just sharing this in chat box also. Yes, so that one also, and another one to sign in. Because for invoking of this cloud platform, everybody should have their own account. So in that account, you'll find that they have giving 50 MB of space, 50 MB of space, free space to work of your own, to upload your required data there. Okay, and this one is things. Another one is with a very important framework. I'm just telling about this one, and you just install that one also. That is the map store. Is also one of the open source things. And along with map store, if you want to invoke that map store, you also require one web framework, that is with a Tomcat. Okay, so I'll share all these things, but first of all, you just download and keep in your system, so that the time is purely short, or maybe after that we will see the things. I'll share all these things then. Okay, then another one things that so in these two ways you can see how that geospatial cloud computing can be possible. Okay, so this is be my main topic. And also we know that you all of you have been doing that, all the participants is coming from different parts of our India. Then we have collected their location points, and I have how much you have get from you people. I have just giving one example for that. Don't worry about that, my name is not there, your name is not there. So it is only just I have giving one type of demo things, and you can do that things. And one more thing is that, so any peoples, those are working in any other sectors, that geospatial technology is just like the pinch of salt. You can integrate this model, this GIS model, in any sectors. Some ma'am was telling yesterday that how we can integrate my chemistry with my geospatial technology. So I have also given so many ideas that you can use your these things in your research also. Okay, so this is all about the lectures what will see. And another thing is that so I have done my about me some. I'm just giving some um, uh, academic qualification of mine. I have done my PhD from MNIT Allahabad. It is known as today. It is known nowadays. It is known as the Prayagraj, India. And my thesis is on development and implementation of interoperable and secure SDI model. SDI is with a spatial data infrastructure model using open source GIS. In 2012, I have completed my PhD, and in MTech also simultaneously I have done in 2007 to 9. And in that case, I have just work in WebGIS and the WebGIS framework for development of spatial data infrastructures by the integrating of all those possible open source software at the time of 2007 to 2009. At that time, I have integrated all these so open source and to develop one spatial data infrastructures for sharing of your spatial data. To sharing of your spatial data nowadays, you know that SDI much more popular nowadays. Every states they have their own SDI, that you can share your own geospatial data across the web. And also you can share your different kind of data. You maybe in health sector, you can find out every collection of data, every government, they are providing the free data services to the common users. And also you can share, you can update, you can visualize, and also you can anything else you can do in your SDI infrastructure through the geospatial technologies environments. Okay, then basically I'm working in SDI and some of the GIS technology, and how can integrate with the IPR, intellectual property rights, and main focus is in database engineering. And also I'm working on geospatial cloud and fog computing also be there. It is been now one of the emerging field. And in fog, due to that IoT, Internet of Things, which has been integrated with your geospatial data. So how a geospatial data has been integrated, I will give some of the ideas that how geospatial data has been integrated with our Internet of Things devices. Everywhere you can find in smart cities, or maybe in smart environment, you can see that the geospatial location services, has been integrated with the IoT, and you can find out this in platform for every analysis and designing purpose. So today we'll see. I hope you have going through the GIS technology, and just I will give you some overview idea of GIS technology, then about GIS analysis. There are different type of analysis we have doing through the GIS environment, and also geospatial web services. This is very important for the geospatial cloud computing, and we will just discuss about these 4 services: web map services, then web coverage services, web feature services, web registry services, and also with that services, we'll go for the geospatial SOA, service oriented architectures. Okay, that is with the one timeline features is there. In early, how they are using the internet, they are using common mainframe, then they are using the desktop. After that, they are using the common client service architectures. Client, one server is there, and client access the data through that server. Simple invocations of data, statistical data, or maybe static data which has been stored in server, and we can share our data through that client server mechanisms. After that, we will go for the web services. That means we can update, we can share, and everything else can possible through that client service architecture. Then after that, we will go for the SOA, service oriented architecture, for our geospatial computing framework. Then we will go for the cloud. After that, the cloud, we will go for the some fog environments. It is very interesting field. There are so many people that are working in this geospatial fog environment. And also it is with the fog is nothing else, it is with the assisting technologies to the cloud. Okay, then you can go for the some ideas about the big data. Then we will tell about the open source GIS software. Then I will share about the some demo on QGIS and MapStore. So this is be my outline of today's lecture. And in GIS technology, as all of you know that it is be the integrations of hardware, software, and data, which is used for the capturing, managing, and analyzing and displaying all forms of geographically referenced informations. And also, you know that it is be used for the viewing, understanding the things. You can also interpret your questions as well as interpreting and visualizing. Very important is that to visualize the data and to make some kind of relationship, and you can find out some patterns and the trends in the form of maps, or maybe in globes or reports, and in terms of charts as well. So if you all talk about in framework structures, GIS is basically this requires some data also be there. Then you can also find out some of the hardware components. Very important in terms of whenever you do any GIS based applications, you have the main component, data you have to require for specified hardware. Then after that, you will require some of the software. Either maybe you will go for the proprietary one or maybe open source one. And after that, the main important part is the users. So they have the different categories of users are there, starting from the applications programmers to end users to GIS database administrators. So they have, all has been integrated to make one GIS system, geographical information systems. So all of you know that the basic concept is that you can find out a panable and zoomable map, so that every kids maybe know about what are the main scenario of this technology, isn't it? So like this, we have to find the component of basic component concepts of GIS. And also in terms of GIS, as you know that the main idea is in a first, you know that the main idea about the GIS, it is in early 1854 by Dr. John Snow's map. Okay, so it is been for the find out the cholera outbreaks. So from this map, they find out that is some of the cluster where they are according to their point data, whatever they find, some of the cluster has been happening here, and with that cluster they find that some problem happening here, and they have rectified their problems. Okay, by this common map in early 1854. Then you can also find out that the intelligent map with the overlay analysis, you can do a different type of 3D, you can map with some 3D components with this image, and you can find out so many intelligent maps. And it has been much more popularized due to the 3D GIS model, isn't it? So that is one important criteria, important things you can find in our GIS technology also. Then also it is also with the time analysis features. You can find that the railway road in the United States, that it 834 to now, till now, how that has been integrated with the GIS. And you can also do that time series analysis. For example, in this pandemic situation, if you find out from the beginning of from 2019 December to till now, how much people has been getting infected by the coronavirus, and how much they have the death report, you can also find out through the GIS, and also you can visualize through the web also. So by integrating this GIS technology. And also you can find out some of the aspects of geospatial coordinate systems. As you know that that longitude and latitude concepts, that it is very important that the red mark is purely as given as the range, which is range is from 180 to 180 degrees, and it is in terms of the longitude, and the latitude is the black mark, and it has been ranged from 90 to -90. Okay, this is with the general coordinate system, and everybody should know about if you have to work in GIS, the coordinate system is very important. So you can find out this the common things, and the longitude, in terms of longitude, it is with the purely from 180 to -180 degree, and also latitude you can find from in black format, then it is be in 90 to -190 degrees. Okay, so this is with the common structures for the geographical coordinate systems. And also, whenever you have to find out the coordinate capture through, this is the Google map. Somebody, if want to find out the coordinate system, just right click on that, and then you will find that get coordinate systems. So that coordinate system we find out from Google map as well. So that coordinate is also helpful for doing any type of analysis, particularly in the point analysis or maybe hot map analysis. At that time, this coordinate feature is very important. Then the data model also be in GIS also be, they have the categories into two types of, one is the vector and another is the raster. As you know that the vector is be represented with the line and point and polygons, whereas the raster is be defined with the pixels. Here, so all these real world entities can be represented by the vector as well as the rasters. So vector is be calculated to be represented through the point, line and polygons, whereas the raster is be represented with the pixels. So they have already yesterday I have just also discussed about these things, that vector is be defined with this files, KML and geo database. In raster you can TIFF, JPG, PNG and image files you can find. So they have the fundamental data types. So every GIS should have their different data types. As you know that the data according to the data model, vector and raster. Vector is be point, line and polygons. And it has been some non-geospatial that tabular attributes also be attached with this line and point polygon features. And in terms of rasters, it is with the pixels, and you can find out the basic GIS data types for implementing or to implement in your GIS model. So vector representations, line, point, line and polygons, and that point has been different with the different type of cities, then the different road network and different type of polygons also you can find for the represent of any maps. Then in points also you can categorize in accessible through the attributes, and then it is with the streets also, and whenever you have to talk about the polygons, you can also access through this attributes also. Then raster represents all, you know that raster can be represented with the pixels. And one pixel is be represented with the 1 point, and lines also be number of neighboring pixels which is be defined as the line. Then polygons also be there, and aggregations of neighboring pixels, that is with the polygons, and the polygon features is represent like this. And we have also discussed about the different data structures which is be used for the GIS, static from the hierarchical. This is be very old one. After that, it is visualized to the tree views, and this is with the network model. This is with the relational model, and in the GIS basically we have to deal with this relational model, and also you have to also the advanced version of relational model, that it is with object oriented data model. They are the mixed together, and nowadays it is be coming under relational data object oriented data model, database model, relational object relational model. Maybe it is be sometime known as the object relational model technology. Then you can also know about how to integrate creating the geospatial database. First of all, you are entering the geospatial data, entering the attributes. Then you have to find the geospatial attribute data verification and editing. Then linking the geospatial and attribute data. Just you know about how we can do these things. And the linking is very important, and they have so many algorithms are there to link with this attribute data. So you know about how to do the queries. There have been two type of things: attribute query and geospatial query. Attribute query is simply you can choose from the tables or that link tables. Okay, and also geospatial query, that is by clicking on the features on the map to find out their attribute values. So this is one example that how we can go for the attribute query, that the lung diseases in 1860s, and it has been find out from that attributes. So you can do that through the query building tools. And that is we find out that this is the query select areas where mortality rate is greater than 58.0. So that is the purely one type of SQL queries. Structured query language is there, and through which you can calculate these things, and it has been represented through the attribute query. Then it is with the geospatial query, just click on that and you will find the details, and through that particular features we will find the values. So this is with the coming under the geospatial queries. Then mapping, you can also know how to map in the QGIS. It also be giving the mapping tools, and you can find out how they are distributed, all the values on that in mapping technology. Mapping print map through the QGIS. And in terms of the analysis kind of things, you have two type of analysis, maybe other analysis also there, but I'm just discuss about some of the overlay analysis and buffer analysis. In overlay analysis, we'll do some vector and raster analysis. So in vector analysis, just see that we have two layers and it has been integrated with that, and we'll get the resultant map. In terms of raster, just see about how we can do that is with the soil map, cover type, and we'll get all the resultant composite multi attributes through the raster overlay. Then buffer analysis, very interesting analysis in GIS, and it is very handy also in terms of doing any buffer analysis. You can find this type of buffer analysis also in they have in QGIS also, that say buffer geospatial analysis part. This is be the one point. Within that point, you will find that in their radius, how much it has been accessible with the elements. And one more example, that if you'll find that in this case you can use that buffer analysis, that means how many tobacco said retailers are within 1/4 mile of all schools. So by doing this point features buffering, and we'll find out the details. This is be the point features of buffering, this is the line features of buffering, and this is the polygon features of buffering you can find from there. So now it is be part of your geospatial web services. I have already in beginning I have already defined that the initial phase, whenever do any geospatial analysis, it is be going through the mainframe computing technology, in which you can do some of the geospatial analysis. After that, we will go for the client server analysis. Client servers means you are the only client and one server is there, and in that how you can communicate with that server. That is the main fundamental client server mechanisms. Another one is the web server mechanisms, web services. Then web services, that means in client server only one services you can invoke in a time, but in web services you can invoke more than one services. Maybe for example, that in terms of geospatial analysis, somebody is doing buffer analysis of point, somebody want some line buffering analysis, somebody is one polygon analysis, but these three cannot be possible simultaneous in this technology. It may be in early 2000 or 2001 they are doing that type of client server things. After that, it has been designed with that we can perform more than one job simultaneously with the concurrency mechanisms. That means we have to use somebody is doing some buffering of point, somebody is doing the buffering of the line, all along we can do through this web services. Then in SOA, what happened in every companies, they have integrated their all these web services in one catalog services invoke in SOA. I will tell this in these structures, that all these structures has been integrated in one platform, that is been in catalog, and according to that catalog, user will choose which type of services they want to invoke. So that is with the SOA service. Then after SOA, the famous one is that nowadays we have everybody using the cloud services, cloud computing, and after that in cloud we will go for the fog computing. And in this fog computing nowadays, it is one of the greatest challenging field in geospatial computing field. So this in this computing field I have initiated in 2015, and I am the first one that this type of technology integrated with the GIS. And this fog GIS framework is now much more popular nowadays. I have got citations within 2 years, 65 citation I have got, and within that 34 SCI journals has been cited for this fog GIS framework. So in early 2015, along with my student who is working in University of Texas, and now he's in Microsoft in their deep learning code team, we both integrated this fog computing with GIS, and that paper has been cited with more than 65 um, 65 papers. And also so many people from in cloud computing areas, they are using this type of framework. They are referring my fog GIS framework for implementing these things. And also I am just telling about this one in detail, and that web services is that you have the common web browsers. Okay, just like that of your Mozilla, maybe your Chrome, all this common browser is be there. And what you have to do now, you have to access this GIS server, and GIS server has been integrated with this GIS database. So software and database integrated with this GIS server, and that server, these things has to be connected with this web browsers. Simple one. That web browser is your Chrome or Mozilla Firefox, any browsers. That browser has been connected with these things, with this web server. Okay. For example, in my demo session, I have already giving the link that you have to just download this web server. This means Tomcat, isn't it? Tomcat. Maybe according to your things, I have given a Tomcat 8. This is the purely web server, Tomcat 8 web server. Then then after that, I am telling that you just download that map store, isn't it? Map store. So this map store is only for working for this GIS server. Whatever you have designed, it has been stored with this map server. So you require Tomcat as a web server, and map server is for all doing all these things. And you have simple what you have Internet Explorer, or maybe you have Chrome, or maybe you have Mozilla. Okay. So all of you understand what are the why I am giving the link of that software. If anybody doubt, you just ask me now. I've given two links, one for the Tomcat, another one is for the map store. And also they have several GIS server also there, but today I'll tell about this map store. I hope all of you have downloaded that one, or you have anybody facing any problem to download this Tomcat and map server, map store. Yes, I'm audible to all of you. Okay, so for that reason, we are using that map store and Tomcat. But in terms of that QGIS plugin, I'm just telling about why you are using that QGIS. That QGIS plugin also be coming on in this picture also. So that Geospatial Web Services, it has been implemented in two ways. One is the thin client, another one is the thick client architecture. Thin and thick. It is very important in terms of Geospatial Web Services scenario. That all of you know about, you are using the Google Maps and Google Earth, isn't it? So Google Earth and Google Maps both has been the product of Google, isn't it? Google Map and Google Earth. So Google Map is purely thin client architecture. Google Map, and Google Earth Google Earth is purely thick client architectures, thin client and thick client. So because why it is big thin client? Because this Google map can work only in the browsers. In browsers it will work. That means all these server kind of application, server side of application, they have one client and server is there. So in browser there is no any server side of work has been performed there. All this kind of performing of this operations has been done in their server only. But Google Earth, that means you have to install that Google Earth in your system, and you have to connect with that model with their server. But nowadays it has been integrated with your browser also. Google Earth also now it has been integrated with your common browsers. That is one of the advanced technology. Due to that, Docker is there, one Docker and one VM virtual machine. Due to this virtual machine and Docker or container, they have integrated this Google Earth in browser also. You can work in browser also. But the basic difference is that thin client and thick client. That in thin client you don't need any extra software. You just use your browser and use that applications. But in thick client, you require to install that system, that product, and after that you use. That means some kind of operations also work in client side also. So again, the best example is your QGIS. QGIS is purely thin client architecture, thick client architecture. Because why? Because you just install that product QGIS, either it may be 2.1 or maybe any version, you can install that one, and you install that product and use according to your requirement. But whenever I'm telling that you just integrated your thick client with simple server, just what I'll do that demo sessions, that you just install that plugin, connect that plugin, and you upload your data through that thick client, and that data has been stored in their server. So that is the part of your thick client architectures. So I hope all of you are clear about these points. Your QGIS software is purely thick client because we have to connect with the server. I will tell you the demo how we can connect with your server, because you have already your account you have signed in that account, and you have the username and password, and you have to give the username password with that cloud plugins, QGIS cloud plugins in your QGIS background. Okay, so that is the basic difference between thick client and thick client, thin and thick clients. So the common browser, the product which is be running through the common browsers, that is the thin client. The product which has to be required to install in your system, then you will invoke that services through that server, then it is the thick client architecture. So in thin client, I've already discussed that you have the common web browsers and all these things in server, and we have to connect with the internet. So that is be derived from 2002. They have been using this type of technology in geospatial framework. Then web services in thin client environment. So in thin client environment, we have invoke. They have the four. They have also they have the total 18 to 19 services are there. But the common web geospatial web services are web map services, web coverage services, web feature services, and web registry services. So what is the difference in between that services? That means whenever you want, only invoke the map only the map. Without their feature extractions, and you cannot find any coordinate also. If you roll over that map with that in that web services features in that browser, will not get their coordinate. Only you have to retrieve their image without their coordinate, without their features, then that is known as web map service. Whenever we have to retrieve that map along with their coordinates, if you mouse over that and you will get the coordinates, then that is known as the web coverage services. Another one is very interesting that we will see in the demo. that web feature services, WFS services. In demo, I'll invoke this web feature services. That means whatever you will get, the maps, the informations, you can get their coordinate as well as their features. So that it is known as web feature services. Another one is the web registry services that I have already told you that whatever you have doing some invocations of your services, it has been listed down in that that framework, that this type of services has been there, and you just click on that and you use that services. So that services can be invoked by the web registry services. So these are the common 4 services which has been very important in terms of geospatial web services. So web map service already have given that the map services which provide the image file and graphic language like SVG and GeoTIFF, common GeoTIFF image, and that OGC web that OGC has defined this web map service provides the maps of spatially referenced data dynamically from the geographical informations. Open Geospatial Consortium, they have given this standard that only you can retrieve the image from that reference, spatially reference data, then that is coming under the web map service. Web map service enables the creation of the network of distributed map services, and from which the clients can build customized maps that it can invoke using the standard web browsers by submitting the request in the form URL. So this is the one example. Just see here the Google map. Only you can visualize the queries, and somehow you will also, nowadays it has been updated so many things, and you can only if you visualize this screen, only they visualize the map without their coordinate system or their feature system that coming under the web map services. Then web coverage services, which is be returning the coverage data to the user. It is return the actual raster data, and it is giving the geographical coverage across the web using the platform independent call. And yes, any questions? And then you can also find out the interface returns the objects or image in the geographical area, whereas the WMS interface returns only an image. That is the basic difference. Geographical area points, but in WMS you only return an images. It has been specified in OGC. They have specification. They have defined that things. So this is one example here. It is the invocations of one open layer through the open layer. You can find, if you mouse over there, then the coordinate system will be invoked in that way. This is the one example of web coverage services. But whenever you click on that, you will not get their retrieving data. So how we can retrieve? We can retrieve through the web feature services. So in web feature services, it returns the actual vector data, and a web features service standard provide an interface allowing the request for geographical features. You can find out the features across the web using the platform independent call. It has also specified in 2005. The OGC WFS specification defines that the interface of data access and manipulation, suppression and geographic feature using the HTTP, hypertext transmission protocol. So they have HTTP, whatever we have accessing the elements by the HTTP or HTTPS. If you want the secure things, that the secure part of things, if you want to access that elements, so you can use the HTTPS. Very interestingly is that nowadays we can also using the blockchain with your GIS. Nowadays everywhere else you can find out that how much you have secure, because security is main concern in our geospatial technology. So for the security also, there are so many people are working in blockchain with GIS also. For the smart contracting, or maybe they are sharing the smart location analysis, they are also using the blockchain technology in that case. So I see this is the one framework which I have been developed. In 2009, I have developed this framework that I have integrated all NITs in one platform. This is in yearly. This framework is in 2009. I have invoked WFS services that all these NITs in India has been integrated with one platform. If you click on this NIT, or if you click on these locations, you will get all the details of that features, and just click on that, and then you will go for that main websites. So this has been one framework, and I have achieved these things in WFS interface, and it has been achieved through the GeoServer. GeoServer is also one of the interesting Geospatial web services product, open source product, where you can do that type of things. Then web registry services, you can use the metadata. Web registry services represent many metadata structures, which is composed of locations, geographic operations, topological analysis, and transmission data format, and invoke many services. That means it has been used this technology that this metadata repository is there, and that metadata has been repository is there, and it has been stored, and it has been connected with the applications client. So this is the common structures of the web registry services. Then this is with all these structures has been integrated here. I have stored all my services and listed here, and according to that, somebody is going to click on this and they get the services. Open through the open layer, or maybe GeoESS, or maybe a PDF, maybe any kind of SVG, any type of things they can going by the single click on this registry services. Then the thick client is that some of the component is also be in web browser required, but some of the component plugins also be attached with their client side, and server side also be they have taken the same things. That this type of APIs and this type of things has been stored in client as well as in server. This is with the server side. Now the main things is Geospatial SOA. That means service oriented architecture. Here just see they have main important layer is that 3 layers are there. Very important layer is there. One is the consumer, and this is with the compositions layer, and this is with the producers. Consumers and producers. In terms of geospatial analysis, you know that desktop is also one of the important component for the users. Heavy that terms are the desktop heavy. Then desktop that you can use the laptop version kind of things, which is the light versions is that. Then you can use the web browsers, mobile devices you can use. Then service calling a service. That means whenever you have to use any API, for example, for your work you are using open source that Google Map service, Google Satellite service. Maybe you can use Wikimap service, or can use OSM service. That service calling also be there. That's also be coming under consumers. And portlets, that means we have to use the attached forms along with that layer, along with that application. So this is all coming under the consumers. So consumers is there. Consumer is using the producer things by this intermediate layer. In that intermediate layer, you can find applications. In applications, you can find the rich client applications. That means all these product which has been already designed, that has been placed with the rich client. Web apps, the application software which is be attached with that. Different API. That means you can use others APIs, and you can use in your phase. You can also use that one. Then mobile API also you can use in this case. And service support. They have different type of security aspects, management aspects, semantic aspects, or orchestrations, and directory. All has been supported by these service supports. And main important is that services. See, they have so many map services, open OGC services, image services, analysis services, and metadata services for the searching, and for the registry service. All has been defined with the data centric services, and it has been defined by the different producers. Producers always giving their producing elements, that they have storing their data in the RDBMS form, flat files. The files has been stored there. Then their search engine mechanism by the different organizations, hosting providers, enterprise applications, they all are coming under this producers. So this framework is basically known as the SOA architectures. In this SOA architectures, you just find that all these applications has been integrated with the consumer and producer. And the consumer producer has been using this middle tier by the registry services. All this type of service has been registered here, and it has been invoked by the consumer, produced by the producer, and consumed by the consumers. That is the general architecture of geospatial SOA. For example, is that we have one company, is the ISRI is one company, isn't it? ISRI is one company. They have their own SOA architecture. Same like that, you have INB also. INB also they have producing their own architectures. Then IRDAS also they have own architecture. They are using Apollo Web Services. They have their own infrastructure, their own codes, their own features like this. Is exactly ISRI also they have one common web services there. Then Arc server. So they have also they have their technology also be different one. So in geospatial SOA is that they have their own companies. They have different companies that their own platform or their own framework to invoke all these applications. So it is very difficult that if somebody want to do to establish their own web services, then they have to purchase from the IDAS Apollo. So we have the IDAS Apollo. It has been very much more cost, and if you want to integrate it with the Arc IMS server of ISRI, then they have their own framework. So whenever you have to integrate, you will face lots of problems because they have their own standard. They have written their own code, and whereas in Arc IMS they have also their own code. They have their own standards. They have specified own standards. So whenever you have to integrate this to Apollo with Arc IMS, then it is very difficult to implement that one. By how we can integrate it? Now it is very difficult. We are doing through these orchestrations and choreography. So some company, for example, that our ISRO is using that Arc IMS, but in DRDO they are using IDAS Apollo. In some sector they are using Apollo. So whenever they have integrated to each other, it is they have getting so much problem during this orchestration problem. Okay, so that is one of the main difficulties arise in this framework, geospatial SOA framework. So to resolve that one, we'll go for the next phase. This is with the geospatial cloud computing. The advanced version of SOA, service-oriented architecture, is geospatial cloud computing. That means SOA has been integrated with the geospatial technology, that is with geospatial SOA. If the cloud computing has been integrated with the geospatial technology, that is with the geospatial cloud computing. So whatever the problem we have arise in case of your SOA framework, it has been resolved by a cloud computing. That means all they have using the common framework. Okay, they are using the common framework with this 3-layer technology. That means this application layer, they have used the common properties. They are sharing the common properties about this framework. One is the client layer, one is the data layer. In data layer, they have storing all the type of data is there, and in case of application layer, they are using different server. For example, if somebody is want to store catalog services, that means all the registry service has been stored here. That is coming under CSW, catalog services. Somebody is using that data server is used for the WMF web map service, web feature service, or web coverage services in this data server. Somebody wants to store all these web processing services. This is also very important. Web processing services, they are using processing server. And in web processing services, there are so many libraries are using. And those are doing some, as you know, GIS is purely used for some analytic purpose. So I am just recommending that whenever you have to do any web processing services, you just use R and Python. R is one commonly used, and you can use the R for your geospatial applications. Along with you can use Python. Nowadays, Python has been doing in every field. Any kind of analysis features, you can find so many libraries for Python. Okay, so you can use that one also. So for this, we have used internet, and we can use some of the server side applications. For this client side, you have mobile client, or maybe you can find thick client. See this Quantum GIS. I've already discussed that Quantum GIS is purely thick client, Because why? Because we have to install that QGIS, and after installation you have to give your username or password, or maybe you have to, after installation you can invoke the services through the cloud platform. And also thin client, here see, thin client is your browser, web browsers, and they have the map renders or many applications which is used for the thin clients. Again, it is very interesting. After that, geospatial cloud, we have find that this geospatial fog computing, and it has been published already. It is in 2015, but it has published in 2016, and the conceptual diagram here. What happened in cloud platform? Whenever client interact with this cloud, it will take lots of time, and it has been so many. Whenever we have required small applications, we require overall this big applications for executions. So that in between, I have taken one another, in between the client and in between the cloud, we have integrated one another layer, that is the fog layer. As in the cloud and fog means it is a small droplets of cloud. So that means IoT is the small devices, and through this IoT is purely small computing devices. Through this, we have integrated with our IoT devices, and for low power consumptions, for reduced storage space, and it is high efficiency also. Due to this high efficiency, this framework is now, it has been integrated in every aspects of life, in terms of smart devices, or maybe in terms of geospatial healthcare services, or maybe in terms of smart cities, or whenever we have to go for the smart supply chain management, we are using this type of technology. In every smart city implementations, this framework is now, they have recommended this framework. Okay, so that means we will not directly connect. That the main thing is that in fog computing, just for the fog computing, is that we will not directly connect with this cloud. You can make one medial tier, and whatever the services required, we have to go through this one, and we have to connect this one. Yes,
Dr. Barik,
yes,
Dr. Barik,
yes,
Dr.
yes,
Miyardas here.
yes, yes.
So please refer to this chat section so that some queries are there. Please check in.
Okay, I'm just
Okay.
checking. Yes, okay. The QGIS cloud downloaded and sign in, but not able to proceed step 1, step 2. Okay, I will tell. But you just install, just download that one, then I will tell. But I hope all of you have store the QGIS cloud plugin in your QGIS environment. Okay, so the step 1, step 2, I will tell, because it will be required to install in your system. So is it okay? Okay, so now this is with the fog environment, in which we can access the geospatial component through this layer, and we have to storage, or we can do the analysis by this cloud layer. Then geospatial big data. So it is also one of the very interesting area, and it also be integrated with your geospatial cloud computing scenario. Because why? The cloud computing is purely huge framework. If you are working in a small things, just example of 5 MB of 50 MB of data, then it is be unnecessary things. So whenever you have to deal with a huge amount of data, just like that of weather forecasting, or maybe you can go for some storing of satellite images, it has been huge amount of memory space as there. So for that, we have to dealing with some big data in terms of geospatial big data things. So in big data, so big data are that the data sets that are so big they cannot be handled efficiently common database management systems. So for that reason, we go for the some big data type of things. So in common relational database management system, just like that of your MySQL, maybe in a PostgreSQL, they will not handle that type of huge amount of data space. So for that reason, big data is playing in that scenario. So geospatial big data represents the big data in the form of geospatial layers and attributes. And basically in our geospatial field itself, it is the big. The data itself is a big according to their volume, varieties. Okay. So that itself has been the terms as the big data. So So source of geospatial big data includes these are the GPS. Maybe it has been GPS enabled devices, satellite remote sensing, aerial survey, radar, lidar, sensor network, digital cameras, the locations of reading of RFID. All has been sources through this. You can get our geospatial big data. So in terms of geospatial big data, we have, depending upon the 5 V's, that volume is that how much volumetric data you have to get from the satellite imagery, covers the global globe, so is fast. Sensor data also be there, digital camera also be there, then that give rise to the volume of the data. Then the variety of also be there. You can find out they have the 2D or 3D variety of data. Either maybe it is be from vector, maybe, or scalar. You can find the different variety of data, so that it is part of your characteristics of your big data. And also velocity is very fast in the image travels at speed of light, so that the velocity also, the huge amount of velocity of data is coming, then this terms as the part of your geospatial big data. Then next two is that veracity. The veracity is that the for vector data, the points are there, the quality of data, it depends upon the whether the point have been GPS determined or determined by the unknown origins. That means how much accurate data we can find through these vectors or as well as in the raster data. Then you can also find out the values, different type of values from real-time geospatial big data. Decisions can be enhanced through the visualizations as well as for the dynamic change in the such geospatial phenomena as climate, traffic, or social media based attitudes, and massive inventory locations. Also you can find the different values. You can also express the data trends on the including spatial proximity and relationship also. So in terms of overlay or autocorrelation analysis, or maybe buffer analysis, you can find, or maybe in geospatial clustering technique, you can find also different type of data, so that according to these 5 things we will get the geospatial big data. Okay, so just for big data analytics, it is very interesting also. So everything is related to, as you know, that in first law of geography, everything is related to everything else, but near things are more related to than the distance things. So according to that law, you find that the big data analytics in terms of geospatial big data analytics, it is very helpful. And also you can find out some eco routing mechanisms, or maybe you can find out the faster routing mechanisms. You can find this type of analysis also very it is be required for this big data analytics. So data driven and real-time science also be required some of the analysis features. I think you will go for the lab demo sessions. Okay, so I'm just skipping these things. And now the open source, as you know that the source code may be available for the modifications. You can also redistribute the data, and also you can derive the work, and the license doesn't limit where or whom by whom you can use that one. So for that reason, the open source now it is very much popularized. So open source, as you know that it is be purely freely provided, but it close the proprietary one, it is be developed with the common peoples, or maybe it is with the farm which is hire the programmers, and it is be limited, but it is not in the limited, and the very large number of programmers are working on that, but here the limited people working there, and it is be programmers compete with them, which is each other, but here you cannot find that type of scenario. You haven't paid for anything else, but you have to pay the price for that. And less time and effort we find here, but here you can find the more time and space effort has to give in terms of open source, in terms of closed source. These are the main basic differences between the open source and proprietary, or maybe it is the closed source. So in terms of open source GIS, in early 2007 or 2005, it has been categorized into the 2 parts, maybe C or C++ based or Java based, but now you can integrate with the Python also. Python based. So many open source software you will find that in C++ based or Java based or in Python based. So it can be also categorized into this. And in terms of geospatial open source GIS categorization is based upon geospatial database creations, geospatial analysis, and geospatial web services. So for the creation, I hope you have all of have been using this Quantum GIS, but Louis also be there, and OpenJump also be one of the good open source software for doing geospatial database creations. Geospatial analysis, you can use Louis as well as Quantum GIS, OpenJump, UDIC, GVIS, SIG. You can GRASS also be there. You can do some of the analysis, And you can also find out for the web services, whatever I'm doing, in terms of web services things, you can use GeoServer, Degree, Map Server, or maybe Mapstore. QGIS also be used. Quantum GIS also used for the geospatial web services. So today in demo, I'll use Mapstore and Quantum GIS. So I have integrated all this open source framework. I hope it is be purely they have using the SO architecture for invoke this one. Here see, for storing of data we use PostgreSQL. To use for the geospatial database we use Quantum GIS. And map window JS also be used. Map window JS is also be one of the important criteria which is used for the important open source geospatial software which is used for the geospatial database design. And also you can use JAMP, Apache Tomcat, Geo Server, Geo Web Cache, Geo Network. Geo Network is used for the catalog services. Whatever the services you have done, you can store in Geo Network also. And allow is used for the web feature services invocations. Allow we can use by the, it has been developed by the Melbourne University and it has been open now. And you can use MySQL or MySQL for database stores. So this is with a simple framework structure in which you can integrate all these open source and you can make your own geospatial web framework or maybe geospatial SOA framework. So they have so many companies they are working. Much more popular is CloudGIS, ISRIS Arc IMF, MapStore, Fusion Tables also be there, Google's Map Stores, all CatoDB, they all has been new. MongoDB also be very important parts which is playing for the geospatial big data analytics. And all this document if somebody is want to enter for this. Leaflet also be used for the different type of web services, map services invocations you can find. Then in the open source, if you want to open source GIS for geospatial big data analytics, you can use storage. For storage, you can use GeoTool, GeoMaza, Accumulator, SDFS, that Hadoop framework. Spatial Hadoop is also be there. Spatial Hadoop. This Spatial Hadoop is used for this SDFS. And you can use Spark also, you can GeoSpark also be there. GeoSpark. For real-time geospatial analysis, you can use Spatial Hadoop and GeoSpark. And I have also one paper in which you can find out how you can integrate this Spatial Hadoop and GeoSpark. Okay, so GeoSpark is much more popular nowadays for the real-time analysis of your spatial data. And for processing all this software has been used. And for visualizations, you can use Leaflet, OpenLayer, or MapStore. Okay, and this Quantum GIS is for the both these things. You can use for the storing, you can use for the processing, also you can for visualization. For visualization also you can use the Quantum GIS. So some of the applications just I am telling about, the whole the move bank is that it is giving the detail about all the forestry informations in one platform by the move bank company. And also it is be giving the taxiways, which is be giving all the details about the 5 lakhs taxi trips daily in central New York cities, just giving all these informations in one platform. And this is also be one of the important application of geospatial big data, in which you can find that Obama and Romney, which has been the fight for their company for their elections in October 14 to October 20, 2012, and here it has been analyzed from October 28 to November 2012, how they find that Obama's has been much more popular in this phase. Okay, that can also be find out one of the important use case of geospatial big data. They collect the data, Twitter data, and they map according to their locations, and they find that here and here you purely find that how much Obama has been popularized than that Romani. So the graph is much more here. It is be here and here it has been there. So in terms of visualizations, here see that how the geospatial big data has been used to find out the Twitter battles between the Obama and Romani during their election phase. So they have so many applications areas you can use in the politics also. You can use the in the supply chain management. You can use the public safety. You can use the urban traffic. You can also use in emergency management, healthcare, and climate science and energy. You can also use this one in marketing and advertisement. You can use these things also. So one of the use case which I have done, just I am sending this link. You can check it out that in any one common platform, how we can, this one just check, this one is one platform where I have integrated all the NITs in maybe it is old link, it has been designed in 2018 and all these NITs has been integrated in one platform. Okay. So this is the visualizations where you can find all these NITs has been there. So I hope all of you are getting this link. Okay, so next part is that for map store, just set up your map store in this way. Just download that map store, then download the Apache Tomcat. And just store the downloaded map store to the AR file on this file. Hello, if you have any queries in this, then I will tell the demo how you can upload this one. If anybody having any problem, first of all you just download this one, then download the Apache Tomcat. After download, just install first Apache Tomcat. Okay, in which versions? Actually, you just check your system, in which system you are working. Maybe Windows 32, or maybe you can use Windows 64. In Apache, in Tomcat Apache, just select which bit of operating system you are using. Either it may be Windows 32 or Windows 64. According to that, you just install that one in your system. Okay. I'm just telling you the step, then I'll share my system also. First, you download that Apache Tomcat according to your Windows 32 versions or maybe Windows 64 versions. Then simply install that one. Just double click that and then next, and you just do in this way. Just after that, you just download the map store, and map store, after download that map store, that rar file, and store in program file, because where it is be x86, because I am using 64 bits Windows. Then you find one folder. After installation, you find Apache Software Foundations. Then Apache, then I have Tomcat 8.5 have installed, and then you go for the web apps. In web apps folder, you just copy that map store dot where file. Okay, I hope all of you have got that mapstore.where file, and store in that web apps folder. That web app folder, how you will find? Now you will find from program files x86 slash Apache Software Foundations slash Tomcat 8.5 slash web apps. There you will find in that folder you have to just copy that mapstore.where file. After that, you just click on this HTTP localhost 8081, maybe 8080 there. You just see that 8080 was there. Then map store. Then after that, you can do the default username in that interface is the admin. And password is the admin. I'm sharing my screen. Okay, so here you just check. I have installed the Apache Tomcat. After installation, just check here. Apache Tomcat 8.5 is there in corner here. The simple icon is there, Apache Tomcat 8.5. You just click that one. You just click that one. You will find config and start services, stop services, thread dump, exit, and about. First, you just simply install that Apache Tomcat server, and after installation, you will find this one. Then after that, you will see, you will find PC, Windows, then Windows program file. Here Apache Software Foundation, Tomcat 8.5, then web apps. You go this link. Because I'm sharing it is in my chat. Is it okay? So you just after installation, you will find this for this location folder. There I have stored this mapstore.or file. This one will be the downloaded one. This is be 64.7 MB space. You can download that file and simply store here that WAR file. Nothing else you have to do. Just store that mapstore.war file in this folder locations. Am I right? All of you clear about this one? You just simply install that Tomcat, and in that Tomcat you just see the locations. In that location you have to store mapstore file, mapstore.war file. And after that you have to click on this link, localhost 80801 that map store, localhost 8080, maybe 8080 you have, or maybe 8081. Again I am just sharing that chat, maybe this one, or you have localhost 8080. I hope all of you have clear this one. So just I'm clicking on this map store, you'll get this interface. You'll get this interface. So how many you are getting this interface? Please ping on the chat so that I think you have done that installations. How to install it from RAR file? First install Apache Tomcat. Then put the RAR file, that mapstore.rar file on okay. I hope you have integrated this one. So we'll get this one, these things. Okay, if you haven't, if you have some problem, no, don't worry. I will tell about after this session. I will also tell individually how to compile this one. Okay. So first you have to install the Apache Tomcat. Simply next. Then after that, I have specified the link where you have to put that mapstore downloaded file in that folder locations. Then after that, you have to start the server. Then you have to start the server here. from which file I can install it. That Tomcat file .exe file is there, na? .exe file is there. There you can install that one. So after getting this interface, you just click on this admin. Click on admin, login. So the default login is the admin, and password is the again admin. Then I have sign in. So sign in there. So here I have already stored two files, GeoNITnet and in India place. Here I already have stored two files. You just simply click on this, and the stored invoke values which has been here has been stored. For example, in Prayagraj, if I'll click on this, it will give the detail about your whole details. Whatever you have designed in your quantum GIS, you can upload here, and you can visualize all these things in a simple map. Okay, so how can upload these values? Okay, so how can upload that? I have already designed that file, that save file in my quantum GIS framework. I am just clicking on import. Click on import. Then you select the G file. The G file, that means whatever I've designed here, that file. The file has been designed. This FDP, this file. This file is our main required file I have designed through the quantum GIS, and this is the file, and here I have copied that files. The zip that make as a zip, make it as a zip file. Okay, that new zip file is that which is be our main required file. Just rename according to this FDP underscore RS and GIS, and today's date I am just putting. So this zip file contain all this associated design file. Okay, so that means I have I have stored all this. This one will be the file. That point data has been designed with that, and this file has to be stored. Uploading that file. This one is my file. See, that file has been stored, and I have to just finish that one. See, all these files, the participants locations, if you have to click this one, then you will get the result. Just click on that. So all this detail has been here. Just click appropriate line here. It is by Mrs. Priti Srivastava from Mumbai, and this location has been there here. Okay, so in this way you can upload your design data and invoke your services. This is through where? Through in Map Store. Okay, so don't worry, I'll tell everything. The status server from Tomcat will be icon below right side. Okay, so don't worry if you haven't invoked that one. I'll tell individually, step by step. So just see how we have just check the process, and I'll tell about individually also. So this is the required simple way feature services has been invoked here. So this is be through map stores. Okay, then the simple way in which you can do another way of that QGIS cloud platform, I'm just telling you that one also. Okay, so first of all, you just open your QGIS. Okay, step by step I'm just telling you. So first open your QGIS. All of you just open your QGIS interface. Again, I'm just opening QGIS. I have QGIS desktop 2.18 because it is much more stable versions according to my work. Yes. So all of you have this interface. Just I am doing whatever the steps. Okay. So here just see the plugin is cloud setting plugin is there. All of you are getting this one, or maybe you will find here also there. Okay. After clicking on this cloud setting or plugin, you can find cloud settings. There you can find QGIS cloud environment. Here map, upload data, account, about, all has been there. About, account, upload, maps are there. Okay. In this platform, I will invoke one web feature services. Okay. So for that reason, yes. Any doubt regarding this? So here QGIS cloud, we have map, upload data, account, and about. Okay. So first of all, I will design that Excel sheet. In Excel sheet, you have all your name, your email ID, or maybe your locations, your district name, and your state name is there. So I'm just invoking that one. Browse. I have this copy. That is in CSV format. If you have the Excel format, just make it in just CSV format. Okay. This is my file. Just check it out, right click on this, and you can find the open attribute table. So this is my file. And in some cases, you will see you have to give in latitude, longitude. In this case, somebody has given N, E, so you have to discard that one. Okay. So this is my file. I have the features of total 45. I have collected 45 people's details, the participants details, and according to there, I have respective coordinate is there. So no problems. If you have more than that, then it is okay, no problem. So I have this Excel file, right? This is my Excel file, and you know how to create the points file. This is very easy to create the point file. Just right click on this. Okay. Or maybe you can use add layer. Add vector. So all of you know about how to create the point data from this CSV file. I hope you all know about how to create the point data from that Excel sheet. Just go to the add delimiter text layer. Here, these things, create a layer from the delimiter text file. That means from the CSV file you can create. Then you have to just give the file name, or just give the file you have to upload. So this is my upload file .csv file, and you have to give the X file as a longitude and a latitude. And after that, you have to put OK. And you just see, after giving the OK file, then you have to choose WGS84 coordinate reference system selector, and you have to put OK there. So you just see already it has been created, and I have just this file with properties is like this, and I'm just close this file. This is my updated file. And it has been updated file of my save file, and that save file has been designed. So this is my save file which has been created by that CSV file. Okay, so you can just check it out. If I'll tell, I'll find out the properties, and this is the style label. If I want to give the label, so label name. So these are my file. I have to import. I have to make interface with or overlay with our India file. Choose the reference system. So this is our file, and you can make as a properties, check as a label. So label, give the name, then you have to make as a style. Just put the categorize, or maybe it is give column with, just keep the categorize, then give the name, classify it. So now this is my features. So all of you are getting these features. So just you do that point data and your India map has to be made together. Whatever you have did in your assignments, just make it into your that QGIS interface. That QGIS interface. Okay. So this is my main required data, and that data has to be given the name. Save. I have just saving it. Geospatial cloud. This is my file, and you want to invoke these two file to your Geospatial in your cloud environment. This India and that point data. Okay, I hope all have done these things in your assignments. Okay, so now the next step is that it is very important that in your cloud platform, in this interface you are going through that yes, so you have login, or maybe you have signed in that, and I have signed in with my name and the password is there. So I hope this one also you have done, and you have created one your account, and in that sign in you have just put that one, and you will get in here. You see that they have giving 50 MB of memory space for that. Here you can store up to 50 MB of memory space for your storage capacity. Okay, so after that you just click on account. Okay, in click account and go to the login account. Again, I'm just telling about go to QGIS. How you will get QGIS cloud? Just plug in, and in plugin you can search. In plugin you can search that QGIS. Here you can search QGIS plugin, QGIS cloud plugin. Already it has been installed. So here you have just choose that one and reinstall plugin. So that plugin will be installed in your system like this. and you have this plugin. Click on and cloud setting. You will get this plugin, and just click on. After that, you will find map, upload data, account, about, and you just click on account. In account, you just click login. Login, you have to give username. I have given the username, and the password I have just given here. Wrong password. Why it is wrong? Okay, so new versions is available. Please upgrade the QGIS plugin. Okay. So it is taking time to log in that. So those have done the login, just share your screen in your group, so that I'll able to see how much you have done. Please share your screenshot in your WhatsApp group. So due to the slow network, it is taking time to log in on that. So those are login in login in that, please. Okay, those which have login that QGIS cloud plugin, just share your screenshot in our WhatsApp group. Due to some network issues. Okay, so this screenshot after login, we get this screenshot. Anybody else? Those are getting this screenshot. Please share in the group, so that unable to plug in QGIS cloud in system. Just do the steps. Just go to setting, go to plugins, then you have to manage and install plugins. Here you just check this one. I'm just again sharing these things in your group. Then install there. You just install plugin. After getting the install plugin, you just choose cloud setting. Here you will get plugin cloud setting. There you can give your account detail. Okay. Yes, fine. Okay, great. So yes, okay. So now what you will do, next step is that you go to the account and create. You go to the account and create the link, create the database. Click on the create the database, then you will get this one. The next step is sorry. creating of database. Click on account, then go to the create on database. Choose option. Account option and click on create. So after you have create option, you will get like this, and you choose that one, that database. Choose this option. After creating, just choose this one and go to the upload data. Just go to the upload data. In upload, you will find this one and update data. You just click on upload data. After creating the account, creating after choosing the create option, select that created a database. Go to upload data. Go to upload data. Okay. Then upload data, you just simply click on upload data. Click on upload, then click on upload data. Then upload data. So after uploading, you will find these things. After uploading, you will find these things. So is it clear? So the web map link will be here. This is the web map link. So you'll find, so this is the way in which you can invoke our web map services. Okay, if you have any doubt, anything else, those having some problem in this case, I hope you will get the problem in that case, because it will require to integrate all these things, maybe some so after cloud installations, that means QGIS cloud installations, right? So just choose, okay, after that plugin, after installation that plugin, you just choose cloud settings, then you will get this one. Then after that, you go to account, then you just log in. After that, you just log in according to your QGIS platform. After that, you will give your login detail, then you will find this one. Then you just create one, you just choose the create options. Just choose the create options here. This is the create options. Choose the create options, and after that creates options, you will find like this, and choose that file. And after choosing, you go to the upload button. Then in upload data, you just click upload. After clicking upload, you will go to the, you will find these things. After uploading, you will click on publish map. Click on publish map. Yes, because sums in values. Please check check the long and lat value. In Excel sheet, because if you somebody have giving n or e in that values, then it will not recognize by that system, so it is giving the error. Okay, so it is just download that one. Then after download, I will tell you QGIS plugin is not in QGIS 2.61 versions. Okay, QGIS plugin you can find in 2.18. Just change into the 2.18 versions, then you will get. Any other things? Due to the net, I hope your system, Nandini Krishnan. Okay, ma'am. Actually, you have having some network problem, or maybe there. Just choose according to, if you are using Windows versions, then choose whether you are using Windows 32 or Windows 64 versions. If you are using in Windows 64-bit version, then according to that you have to download that Tomcat. Okay.
Sir, I have made a login through Google, but after that also it is not allowing me to, it says an invalid account.
No, which one? Which one?
So Google GIS Cloud Publisher, the account is, I have made it through Google.
No, it is not able through the Google. You just go to the qgscloud.com. Okay. Go to the QGIS, go to the qgscloud.com. There sign in feature is there. Okay, sign in feature is there. There you just create account. Okay. My screen is visible. My screen visible to you or not?
No, sir. No, sir. Please show it.
Okay. Okay, just see. Whenever you have to click on qgscloud.com, there you will get.
Sir, it's not visible. Sir, your screen is not visible.
I have shared the entire screen, na? Okay, or maybe I am just doing another way. Chrome browsers, then I'm go to the QGIS Cloud. Okay, now it is visible. The browser is visible now.
Yeah. It's visible.
Yes. QGIScloud.com. There you will just go there and just do the sign in procedure. QGIS Cloud free and start out. Okay, you just sign in there, and there you will find your login username and password. Okay, that login and password has to be put in that QGIS interface.
Okay. That is the mistake. I'll try.
Okay.
Thank you, sir.
Yes. Okay. Anybody else? Any doubt? Anything else?
Sir, while uploading.
Yes.
In upload data of
yes.
QGIS Cloud.
Yes.
It is giving a reporting error.
Yes, because why? Because you just check your Excel sheet. Okay, in your Excel sheet, longitude and latitude are there.
Yes, sir, it is there, and it is plotted also on the map.
From the map, but there you just check it out. Ki the values has been put, any N or E value has been put there, wrongly placed there.
I'll just check it out, sir.
Because it's very important that it has to map with that tables.
Okay.
It is with a common mistake. The people, those are beginners, they are doing this type of things, because whenever I have to put the right values, and if some blank values, if some null values may be put there, null values,
and northeast, etc.
Yes. So for that reason, it is be giving the errors.
Okay, sir. I understood.
Because for the trend data, it required that null values must be avoided, and some some kind of the values which has been long and left, it should be accurately placed there.
Okay.
Okay, so after doing that, upload that one, and then you go for the next step is publish data, publish
Okay.
map. Then after publish map, you will get this the web map link, and
Okay.
according to that link, people can visualize your maps.
Okay, sir.
And in terms of any doubt regarding map stores,
Map stores I could not install
okay,
at
okay.
all.
The main thing is that you have to first choose your appropriate Windows versions, either maybe 32 or 64. According to that, you have to download that Tomcat, and after download that Tomcat, just simply install as how you are doing the general software installations process.
Yeah, but
After,
it is asking for Java. Which one, sir?
okay, okay. Maybe they have some distributions also required. Maybe if
Right,
they are telling
right.
the Java, you can also install that Java distributions
Yeah,
through the
okay,
net.
sir. I'll do that later on, sir.
Okay, 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 okay. Any other things? Anybody having any other issues that you haven't integrated your things in cloud platform?
Sir, the same error it is giving after signing also in my GIS cloud publisher.
Yes, yes. You just
That it is.
yes. You have signed in. You have signed in by this login you have given. In you have
Yeah, yeah,
log.
I'm trying.
No, no,
In 3.14, it is in
no,
the
no, no. It is not.
web.
Yes, it is not with the problem. First, you QGIS. You have just go to the QGIScloud.com. There, you
Yeah,
just
yeah, I
sign in
went
there,
there.
and you
Yeah, I
give your
signed.
username just like the not at the rate of gmail.com. You just give simply name, and you have to give the password. Don't give there
Okay.
as a gmail.com or like this. Just give the
Hmm.
username there.
Okay. I'll try.
Okay, okay, okay.
Okay. I've not confirmed my account.
Okay, okay. It has taking given that you just confirm your account. Okay. So this is the general procedure for creating of any accounts. Okay. Anybody else? Any doubt? Any queries? Anything else? And also, I'll share one of my research papers. Also, you will get so many ideas in that case. Just I'm sending you. One paper. I'm sending the links. From there, you also gave lots of ideas. The first paper is that this one is my 61 citation about this fog GIS. I have implemented this one for the GeoFog for health. I'm just sharing this paper that you will find enough ideas, and I have given all these details about these things. So one how to download? Just okay. So I'm just showing you Tomcat for those here. So my browser is visible to all of you. Here you just choose Tomcat 8.5, and here just see core for Windows 32-bit, Windows Jeep, 64 Windows Jeep. This is with the 32-bit, 64-bit Windows service installations. According to this, you just check .exe means your Windows is required .exe format. So choose this one,
Sir,
32-bit,
we are not
64.
seeing that screen. We are seeing QGIS cloud screen.
Okay, okay, okay. I'm just sharing that one also. This one. Okay, now it is be visible to all of you. This is with the Apache Tomcat distribution site. Okay, so here you just check 8.58 is there, and this is a binary distributions. In that, you will find out which versions is suitable for you according to your system. My system is 64 bits. So in 64 bits, this is with the Windows zip versions. That means it is be in binary versions, but you are required simply .exe versions. Means you have to install this one, this 32-bit slash 64-bit Windows Service Installer. If you clicking on this, then you will find the exe format. This file has to be installed in your system, right? Getting?
Yes, sir.
So
Yes.
without this, that cloud services will not get.
No. It
Okay,
is with the
okay. This
common
I
web, because this is with the
okay.
common
I had not
versions.
done that. That is why it is
Yes,
not
yes, yes,
taking.
yes, yes. Because that one is for the map to invoke the map store services.
Okay, sir. Whatever you have taught today, we'll get some content regarding this.
Yes, I'll share. Or you can
Yeah.
also find out from this whatever I am sending this paper. In this paper you will also get lots of idea. Okay, you can
Sir,
also.
please share it on the WhatsApp link. Now this chat will go after
Okay.
the session.
Okay. This is my paper that you can refer. I have already shared in your group. Okay. So, how many you have done that one? That QGIS cloud. Just share your link in your group, or maybe in your WhatsApp group, so that I can see that the people have done that one. Just share your link, the invocations link. Yeah, this one, as I have done this one. Share your link.
Sir, is it necessary to remove null also?
Yes, it is required. Due to null values, it will also creating some problem, because it will not match with that table. It will not imported, or it is be not match with that geospatial cloud database server.
Okay.
So that's much. If you have any, again, I know it is very difficult, or maybe it is very challenging to integrate these things, because the version, the windows has to map together. You have to thought about your some fundamental knowledge for the integrating these things. So that much the things of any doubt, again, anything else. Yes, again, same problem. That means sir also telling that they have some null values, maybe some of the n or e values has been put there. So you have to clear that one. Or I am just sharing my my thing, my Excel file. You just check it out on that also. Yes, I have just shared my CSV file. Just click on that and do the rest of things. I have just shared my Excel sheet.
So, Dr. Barik,
Yes, sir.
now over, it is over. Should we allow them to go for lunch?
Okay, sir. Or any queries? Any 5 minutes maybe. So for today's sir, for today's lecture,
Okay.
I am just sharing
Okay.
one suggestion form to them for this, so they will give
Okay.
some input so that we can rectify or we can address that issues also.
Sure, sure.
So I am just sending that one
Okay.
because they have so many things. I have integrated these things, and within this
We'll
stupid
also share all the contact numbers of the resource persons with the participants so that in future also they can be in touch with them.
uh-huh.
So should we stop now, sir?
Yes, sir.
So thank you very much, sir, for this beautiful session. And I think participants have enjoyed a lot. And obviously, one session is not sufficient to learn so many things. And this WhatsApp group will continue for a bit more till their feedback, etc., will come. That will continue. So through WhatsApp group, they can contact you. They can get their doubts being clarified on the WhatsApp group, and they will be given the contact numbers of all the resource persons. If they want to be in touch with them, that will be there. But right now, because from 2:30, because this is a reduced launch hour, means reduced launch session, that is only 30 minutes. So they have to go for launch and again come back at 2:30. So that another session is there. Then because as per ACT, that session have to be, because 14 session must be there to get the credibility. Then after that, they will go for the exam, and then after evaluation, etc. Everything is over. We will discuss. They have to give their any experience you want to share, any feedback you want to share. You can do that in chat, in WhatsApp, in mail. Actually, that will be recorded, and obviously. After the exam, we will go for the final valedictory address by our Dean, Honorable Dean, Dr. P.K. Sahu. He will address, and after that, it will be over. But definitely, the for 5 days, we have become a family, and the relationship never is over. So subsequently, any doubt, any time, you can be in touch with us, and our resource persons will definitely clarify your doubt. For right now, the session ends, and we will meet again at 2:30 p.m. sharp. Thank you, sir. Thank you so much
Okay,
for
sir.
the beautiful session.
Thank you, sir. Okay, okay, sir. Thank you.